Good morning, this is your Stat Sensei, Mr. Spensei, and here is another scenario for to run a hypothesis test. It's not going to ask us to do the conditions on it. We'll do that on the we will do that on when we do our confidence interval in the next video. So the Ministry of Agriculture is interested in examining possible changes in time to harvest sorghum in a region where it's been recently introduced. Past studies suggest that under similar conditions, time to harvest is 100. To examine whether the mean time to harvest has changed, the researcher collects data from a random sample of 15 fields. So we have a claim of 100, that's going to be important, and we have a random sample of 15 with the following results. Okay, so here's our data. Conduct a test to determine whether harvest time has changed or time to harvest has changed. Well, our formula is T equals X bar minus mu, standard deviation of the sample divided by the square root of n. Please remember, using standard deviation of the sample is what makes this a t distribution. Well, they tell us our mean of the population, that's always the claim, is 100. They also tell us our sample size is 15. We need to take this data and enter it into stat edit, which I've done here in stat. Uh, and I can do this one of two ways. I can go ahead and run the t-test, or I can do stat calc, one var stats, go all the way through, and I find out that, oh, my mean or my sample mean is 107.666. 107.6666. And we have a standard deviation of 8.1034. All right. While we're here, what type of procedure we're going to go? Well, we only have one sample. So this is one sample. What's our distribution? T. We're doing a test. And what are we testing? Population means. All right. When we draw our picture, we assume it to be centered on the population mean, which we said was 100. However, we ended up getting a 107.66, which is up here. Well, that's all well and good, except for the fact, so we know we're going to be shading this way because we're going to be shading away from the mean. However, they want to know whether it's changed. Change tells me this is a not equal to, which means I'm going to also have to shade this way. It's going to be two directions. All right. The word differ, change, or not equal to tells me it's that. So when I plug in, and we can just go ahead and plug in at this point. We don't even have to do our probability statement. We can do that down there. T equals, well, what is our X bar? 107.6666 minus the 100 divided by the standard deviation of 8.1034 divided by the square root of 15. So that's our T. And we'll go ahead and run a t-test here in a moment. But our hypothesis is, well, it's always mu equals something. Well, what did they claim? They claimed it was 100, so mu equals 100. And they want to know if it's changed, so mu does not equal 100. And really, in this case, it's 100 days. All right? So let's go ahead and run the test. So stat test, t-test, which happens to be number 2. Our mean is 100. That's the claim. Our list is an L1. We have not equal, and we press calculate. And I end up getting a t statistic of 2.366. Well, first off, anytime you're working with a not equal to, you have to do a two times the probability that t, and in this case, we're shading up, greater than greater than 3.664, 3.6642 equals a p-value of 0.0025. All right, so here's my key p-value 0.0025, 4 places. And they didn't give me an alpha level. If they don't give me an alpha level, the standard in AP statistics is 0.05. So, or the standard in most statistics classes is 0.05. So, 500. Well, 25 is definitely less than 500. If your p-value is less, you reject the null. All right, so we're going to reject a hoe right there. And we're going to go ahead and write our conclusion. Our p-value is 0.0025, which is less than our alpha of 0.05. And by the way, if you wanted to use a symbol, you could have. Now you state your decision. We reject the null. There is sufficient evidence to suggest that the true population mean time to harvest for sorghum to suggest that the mean has changed. What did we say here? Is different than 100, is not equal to 100. To suggest that the true population mean time to harvest for sorghum is different than 100 days. All right, I'm going to pause this for just a moment and we'll come right back. All right, it says give the meaning of the p-value in context of the scenario. So p-value is a probability we get a test statistic this extreme or more extreme given that the null is true. Well, given that it's actually 100 days, the probability we'd get a test statistic of more than 107.66, there is a 0.025% chance that that would happen. So here's the way we write this up. If if there's 100 days, if there really is 100 days to harvest, there is a, change that to a percent, a 0.25% chance that we would get a test statistic this extreme or more extreme than 100, and how many days was it? 107.6 days to harvest, because you always have to put it in context, by random chance alone. Now, I recognize it's not always going to sound the greatest, but if there really is 100 days to harvest, there's a 0.25% chance that we get a test statistics this extreme or more extreme than 106, 7.6 days to harvest by random chance alone. All right. Um, so basically, um, what you're just trying to say is, hey, we got a test statistic of 107.6, and that's pretty unlikely. There's only a 0.25% chance that that would happen. Hope this helps and hope to see you on the next one. Thank you.